Hello, guys, and welcome back. Before you embark on your cloud journey, I want to walk with you um, the history behind how we got to where we are right now. Now, the cloud is definitely not what you're thinking. Okay, the cloud is somebody else's data center. Okay, but I want to walk through with you, and this is going to be a very informal video, not based on any special technical detail, but really it's a generic discussion on how we got to where we are now. So right from the onset, somebody like IBM made the first computer. For example, this is just an example, okay? It could be any other company, but they were a big player in those days, all right? Now, many years later, the likes of Microsoft created operating systems that run on these machines to do fancy things. So most of you started using things like Word and Excel and everything else from Microsoft Office Suite, okay? And that became a norm. Companies were using that to keep their books and records and creating documents, what have you. Then it came to a point where we started going into servers to run great functions, but at a very high computational output. So servers could have more RAM, CPU, memory, of course, disk size, and could handle great workloads. Okay, so this also became something that we did as a standard. So many companies started using servers on premises. Now, data center is just a physical boundary somewhere with dedicated power, cooling, and everything else with hardware dedicated to serve a certain purpose. So, for example, Amazon has a website, a big e-commerce website called Amazon.com, and every one of us goes there to buy a thing or two. Now, although they host this website, because of the amount of data that they need to hold for clients and even for the inventory of stock, when I say stock here, I mean the items on their website, they need to have a number of servers. Okay, so they could have an application server doing a certain thing, they could have a database server doing a certain thing, they could have a web server doing a certain thing, they could have other servers doing certain things, okay? And so here we are. We have a physical box, as in a machine called a server. And this physical server is rendering a service, of course. And that could be a web server. So you and I can browse to a website. But the reason why we need to build a data center is because there is a great requirement for machines to be up 24/7. As in, Amazon is not expected to go down, but behind the scenes, some servers serving Amazon.com will go down without your knowledge. Why? Because what they do is data centers, they create replicas of these machines. We call them replica sets, or let's say virtual machine skill sets, and they are cloned, versions of each other. And so if one goes down, it doesn't matter, the rest are all up. Then they do important things like load balancing so that your traffic coming to can go to any of these machines. And if there are a lot of traffic coming from all directions, they can be routed to all the healthy boxes. And then the unhealthy boxes are turned off or destroyed. You say, when I say destroyed, yeah, it could be in the world of orchestration like Kubernetes, it could be a pod which gets destroyed. Okay, but then we have one that replaces it because we have a replica set. Okay, so the cloud is never what you're thinking. All right, the cloud is never what you're thinking. The cloud is actually somebody else's data center. Whereas you see a physical building that you swipe in, go through your security, and go and administer this box, or whether it is a virtual machine or it's a physical server. Microsoft, Google Cloud, AWS, Alibaba, or any other ones that may show up in the future, Oracle, they all have their own data centers away from where you are, not reachable. Like you can see from our post, we have Microsoft has some data centers under the sea, okay, and these machines are under the sea running service for data center, and you don't even know where it is. It could be close to where you live. Like at the moment, at the time of recording, I live in the UK South. So I could be building a virtual machine in UK South, but actually be running under the sea. You get what I'm saying? All right. So machines like these are spun up everywhere by Microsoft. Okay. And Microsoft says, okay, I'm going to put all these data centers in different regions, region being the geographical area. So if you're in Africa, of course, it's going to be like that. Madagascar is there. They might put something in South Africa, put something in West Africa, put something in East Africa, put something in North Africa. Okay, in the Americas or in Europe, they could have regions there. Okay, but the regions are just the geographical boundary, but then they have availability zones, which are data centers, okay, in those regions. And of course, when they design these things, they try to make sure that between one availability zone to the other, geographically, they're about 300 um, miles apart, so that if there was a crack or an earthquake here, it wouldn't also affect that data center here. But having said that, they have all these machines going to a certain power source. They don't all share the same power source. So if in England they had these three VMs in the data center, hypothetically they could have this going to Scottish Power. They could have going to British Gas. They could have going to Eon Energy or whichever one's available, Octopus or Synapse or anything like that. Okay, so this is how it works. And of course, the networking, they would have Cisco switches, all over the place. And I say Cisco switches as an example, but whatever choice of switches that they have, okay, and they're all designed for failure. So there's a lot of resilience, okay, thought of in these builds. Okay, so the cloud is not just somebody else's um, fictitious location of a server. It's actually a physical building somewhere that you can never get to. So we could say the cloud, but it's not up there in the skies, pouring down rain with the sun hidden from view. The cloud is actually somebody else's private data center. So you can actually build your own private cloud, as in you can build a physical building like a data center somewhere and then run your services. Okay, so this is a general talk. All right. So whereas you have a machine that sits there and does work for you, data centers, you build a security boundary around it. It's secured. Nobody can get into the building. That's one thing. And of course, you have firewalls to protect access into those machines, but also you take care of power and cooling. Make sure this machine is always up and it's optimal. Of course, you think of creating things like load balancers to ensure that the service is always up because you're thinking of SLAs. And of course, you're targeting 99.9999%. All right. And that involves a special way of designing. Okay. So for that, I would bring you up to speed to the history where we were before. As in, we only had a computer or a server, and now we have a data center or an on-premises place, and now finally we've gone into the cloud. The difference between a physical place and the cloud is not much, except these days cloud providers have made it very easy. With Azure, for example, you have a web portal, and on that web portal you can go and create a resource. A resource would be a VM or storage accounts or database, and you can create your own IaaS solution for the service you're rendering. All right, that was a quick one. Thank you. If you have questions, feel free to shoot. Otherwise, please like and subscribe for more. Okay. All right. See you in the next one. Bye bye.